So here I'm going to show how to run the program, which capabilities does it have, and I will use the example of the synthetic liposomes, large unilamellar vesicles. And here, first of all, what you need to do, you click import, and by clicking import you navigate to where your data is. Here I have the data for different objects, so here I select these LUVs, and you can select all the data files. You click open, then you have to wait a bit until they will appear over here in the imported datasets list. So now when the import is done, here you see the list of files, and here you have several panels that visualize the data. So here you have the intensity traces, and here you have the correlation curves. You have correlation curves from the single channels and the cross correlation curves. If you want to see, for example, only one channel, here you have these flags, and you can, for example, remove channel 2. And then you see only channel 1, or you can pick channel 2 and remove channel 1, and so on, so on, so on. Here also you have several repetitions for every file. So for example, this DOPC cholesterol file has repetition 1, 2, 3, 4, and so on. And you can select, for example, repetition 4, and for every repetition you have a unique trace and a unique correlation curve. And you see multiple spikes within this trace, and every spike will be interpreted as a particle that is traveling through the focal volume, and the intensities of this spike will be analyzed. And in order to analyze these intensities, you need to click here Peak Analysis. And then when you click Peak Analysis, you have the new window. And within this new window, what is being visible here, first of all, of course, it's again this list of the data files. And here you have your intensity trace for, again, every repetition. And here you have several additional panels that we are going to discuss in an instant. And here you have everything to control your analysis. And first of all, here you have the channel pair. Channel pair means that if you have more than 2 channels, here are only 2 channels, so you have nothing to choose from, but there you choose from which channels to construct this general polarization histogram. Then binning means that what you have over here, you can put your traces together in case you want to construct, for example, the histogram that will represent not only one repetition, but everything. And here, for example, if you put 40, you will see over here right now much more points. Yeah. There are so much that they are not properly visible over here. And we can go, for example, to 10. Yeah. And then over here, plot histogram. This is related to this panel, and within this panel, what you see the histograms of the peak intensities in both channels. And you can have peak intensities, you can have peak prominences, and you also, for each peak, you can have peak widths at the half maximum. Here again, you have this display peaks hook, which if you click here, you see which peaks in the trace are considered. Here is the detection choice, and this means pretty much which channel do you use for the peak detection. In most cases, especially in this experiment where you have the one dye with the wide spectrum, which is analyzed in both channels, so peaks in both channels should coincide almost perfectly, but there still will be some instances when in one channel there will be a small peak, and in the second channel there will be something which is comparable to noise. So in principle, what you can use, for example, only one channel. In this case, it's channel 1 or channel 2. Then you have both AND and both OR. So the difference between both AND and both OR is the following. So if you use both OR, it means that you define your peaks in channel 1 and channel 2, and in case your peak is above the threshold in one channel and in the other one it isn't above the threshold, it's comparable to noise, then it's still being taken into account. And the difference between both OR and both AND, in both AND, peaks that are taken into account here must be above the threshold in both channel 1 and channel 2. This is the method for thresholding, and the default method, and to be honest, it's probably the most useful method anyway, is the z-scoring. Means that here you define peaks with how much standard deviations from the mean do you consider. Right now it is here is one standard deviation, so I usually work with 2 because these peaks then are more prominent, so you can update threshold, the number of peaks then will drop. And then what you do here, you say, okay, we have number of peaks and we constructed the GP histogram over here, and we can fit this GP histogram. So then underneath you have this fitting section where you can select also number of components that you are going to use. So in this case it's clear that you have only one component, and here you can just in principle click fit this, and now you have the fitting curve, and fitting curve has here the magnitude, has the mean, and sigma is here. And what now? In addition you have this middle panel, and middle panel is just the intensity dot plot, channel 1 and channel 2. And in this case it's less useful, but in some cases it's very representative and nice. So right now, let's say you did this analysis, and now what you want to do, you want to export this. So here you have the Save Plot Data button, and this Save Plot Data button means that you will be able to save in Excel the data that is used for this plot, pretty much. So here you have your traces, you have your peaks, you have your peak intensity histograms, you have your dot plot, you have your GP plot and GP fit. So when you click this Save Plot Data, now it's gonna last a little bit, because what is happening, it takes all the points from both traces, and it's a lot. So what happens very often, I just do not save traces, so you can unclick over here and do not save traces, and then you will save a lot of time. But in some instances you need these traces. So right now we saved them, so now it's done. And you go into the folder where your file is. So our file is over here, and here you see now this desktop Excel file. So now we open the Excel file. Yeah, it's file is kind of big. Yeah. And now when you see it, so what happens that you have these different sheets over here, and here you have the traces, then here you have peaks, and for every peak you have this channel peak intensity, prominence, width, And here normalized, this is pretty much the channel intensity divided by channel width. I needed it for something, but yeah, I mean, it's not very useful very often. The most useful is probably this channel intensity. Then here you have the channel histograms as they are. If you want, you can, using these peaks, construct your own histograms somewhere in another software. Then you have your dot plot as well, using this channel 1 and channel 2 peaks. Then you have your GP plot. So here is your raw histogram. This is the GP list, the full GP list. Again, this GP list you can use to construct your own histogram. Maybe you won't like the binning as it is right here, or whatever. And here is the fit, and here is the fitting parameters, so you know where you stand. Now in principle this we can close, and we can go back here, and now I will go back to just repetition 1, and then what I will do, I want the bulk analysis. So pretty much I want to analyze all of them except this one, because this one is a bit unique, so we will talk about this one a little bit later. But what I want to do, I want to fit all of them with the same threshold and the same number of repetitions. So right now I'm here, and now I will go through to apply the same threshold everywhere, so the data will be nicely comparable. Then is the PPC cholesterol I see as well. Yeah, then the OPC. And the OPC cholesterol. And all of this right now is analyzed with the same threshold. And what I will do, I will just click fit all, or if you want, you can also tick. If you click fit all, it will go through, but for example, we do not want to analyze this one. So I will just click over here, and then here is this fit ticked. Well, this means that everything will be processed except this one. So then I click here, and it's being processed. Right now you can see your for every fitting it will display this. So now when the fitting is completed, I would like to show how to export the data of this fitting for every repetition, for every file. So as I said before, again, this one we didn't fit. So this we can close now. And here, yeah, in principle, you can also plot something over here, but this will be very small. In principle, what you can do right now is to again select what you want to export. And click the output button over here. Now you navigate again to your data. Here is the folder with multiple files. And over here you have the summary, and within the summary you have for all files and every repetition. So here were 40 repetitions, and for every repetition you have this. You have GP min, GP sigma, and also total number of peaks. Now they are arranged as the columns, and now it's very convenient to just copy these columns into whatever you want to use further in order to plot this data. So this we can close. I won't save anything. And coming back to this special file. Why is it special? It is special because it's the mixture of two types of liposomes that have distinct membrane order, and you immediately from the very beginning can, I will increase the threshold a little bit here. You can see that here in GP as well as here in the dot plot you see two distinct populations, and these two distinct populations you can also fit in the two population manner. So for example here you can select these two components, and yeah, you can click fit this. Sometimes it works weird, so maybe you have to help it a little bit. So here maybe this one you can maybe put to, I don't know, minus 0.5 as the initial parameter, and you click fit this again, and now it fits perfectly. So you have two components, and I will save plot data again. I don't really want traces because it will take ages again to save, and I will just save plot data. So this is done. We go back over here, and here you have this one we need. So we open this, and over here you have again peaks, channel histograms, dot plot, GP plot, and GP fit parameters, and you have GP fit parameters for both. And here you see that you have two distinct populations over there. So in principle, this is one mode of analysis. That's what you can do with the program. In addition to this peak analysis, you can also do normal diffusion analysis. So there will be a separate video about diffusion analysis for the data that is more that is more appropriate for diffusion analysis, because these liposomes, they sometimes give these weird correlation curves, and sometimes it's not so easy to analyze them when you want to analyze these correlation functions, but still it is possible to attempt that. So you can click diffusion analysis, and within the diffusion analysis, let's say I just want to analyze one channel because pretty much all the curves are very similar. And over here again you have very different parameters, and so what is going on here is again that you can select whether you want one or two component diffusion, or if you want 3D or 2D. Right now this is 3D because these are particles diffusing in the solution, and right now I will also fix some parameters. So offset is clearly 1 over here, this we will fix. GN0 we actually need to determine, but I will increase here to some ridiculously high value, because sometimes when there is just few particles it goes through the roof up, and sometimes it's not so easy to fit. And so amplitude we fix, then this is actually diffusion type that we need to determine. Then alpha we fix, aspect ratio we can fix to the aspect ratio that we obtain from calibration. I do not have calibration file right now, but with that a bit later in a different chapter where I discuss how to generally use this program for the normal FCS analysis. And then again, triplet relaxation time is 0.005 because this is the organic fluorophore, and this we fix as well. And well, yeah, you can fit this one. Yeah. So here it works. You see that you have the fitting curve, then you have the residuals also here on the bottom. And then let's say you want to fit every repetition, and I will again click, let's say, fit all, and we will wait until everything is going to be fit. So yeah, so everything is done. And now this one we can close. And now if you want, you can again click output for all of them. So now you see you have the next analysis. This is useful because you have also your old analysis preserved in case you want it. So the new analysis folder, again, you can open the summary, and you see that in addition to the GP parameters, it also gives you this, because we only fitted channel 1, so we have channel 1 diffusion time, channel 1 diffusion coefficient, and channel 1 counts per molecule. These are very useful parameters. And later on, what you can also do, here you have this plot. So plot, what it's going to do, it will plot everything over here, but sometimes it's not very visible. It depends. If you have a big screen, then it will be a bit more comfortable, so to say, to see everything over here. But then there is also this button, and when you click this button, this is something that we call dot plot, and in principle this is again something that you want to study for your dot plot. So for example, let's say you have this DOPC cholesterol data, we select this, and then you can plot, for example, channel 1 versus channel 2. These are intensities, and we will plot it on axis 1, on dot plot 1, and then when you have to also click here. So when you do this, you see this dot plot. Then what you can also do, you do not have to plot your intensities. You can plot your prominences, you can plot your widths, but you can also plot your diffusion coefficients. So let's say we have diffusion in channel 1 and plot it versus GP. We will plot it on the plot 2, and let's plot it for all of them. So this one, and this one, and this one. This one is again unique, kinda, so we don't touch it. Yeah. So here what happens is that you see that your diffusion is almost the same for all of them, but GP is different. So you see that for DOPC, GP is the lowest, and for these green dots, it's DPPC cholesterol, GP is the highest. And again, if you want to save plot data, you can save the plot data from here. And the last functionality that we didn't discuss yet is this one, which is called restructure data. So sometimes what happens that you see that here you have 40 repetitions and every repetition is 15 seconds. And here I did a little bit different. Acquisition where I had long acquisition, but only few repetitions. There are 5 repetitions over here. And I don't like it. I want to make more repetitions, but shorter ones. So what I do, I click here, structure data. And here I select this one. And it asks me how many repetitions do I want. Let's say, again, I want 40 repetitions. And here I apply. And the new one appears over here. So you see the new one. The new one has now 40 repetitions. Every repetition is 30 something seconds. And the only problem is that the new correlation function is only 10 to the minus 3, whereas here, for example, is 10 to the minus 7, because when we form these files from the microscope, it's not those are not raw files, they are integrated, because otherwise they would be too big. So when I prepare the new correlation function over here, it will be not that sensitive towards fast molecules, but for these big particles that we are studying here, it's pretty good. And then if you close here, you see that your new data is over here, and it's usable right now. So this was for LUVs, and in the next videos I will discuss how to analyze other particles that we also analyzed using this single particle profiler.